Welcome to my Introduction to Networking course, also known as ITN. This is the version 7 material preparing learners for the Cisco CCNA 200-301. Cisco curriculum, everything is owned and copyrighted by them. Moving on, we have the ability to verify connectivity. Earlier we talked about ICMP and ping using echo and echo reply. Those allow to verify functionality. We already talked about what different elements mean. A period versus an exclamation point versus a U. All of these mean different things. There's other possibilities like a Q, M, question mark, and ampersand. Again, we've already discussed that when we talked about ICMP. Even though it's outside the scope of this course, those are still really important to know. We have the ability to look at and extend ping. Ping is actually very flexible on its functionality. So if we type in ping on a device like a router, we can actually see some of the additional options that we have. We have traceroute, which we've already discussed in previous chapters. Again, all of this helps verify connectivity. We talked about traceroute being a hop-by-hop response and how traceroute actually increases its TTL based off of how many hops it has. If we are doing a traceroute and we want to terminate it, we can do Control-C, and that would interrupt the traceroute. Again, we can do traceroute on a device as well, but on a Cisco device, it would be Control-Shift-6 to interrupt the traceroute instead of Control-C. Traceroute, like ping, has an extended command set. There's lots of switches that we can do depending on what we want, the functionality that we want. And again, essentially, traceroute allows to see hop by hop between source and destination. All of this gets us the network baseline. That baseline allows us to understand what the network is doing and operating at a certain time. That way, as we try to grow, we can compare growth back to that baseline. We can apply any changes, and we can relate all of that back to the baseline to see if the growth we're trying to do actually does, in fact, allow us to grow. We have several labs talking about using ICMP and traceroute to document the network. So let's go ahead and let's look at host and iOS commands. The host, a computer, if we're looking at address information, Windows will use ipconfig. Linux will use ifconfig, ifconfig. This will show us address information, the subnets, the default gateway, information like that. We can use this to verify our address information. Here's an example of ifconfig on the Linux host. On a MacBook or on an Apple device, you may have to go to the network preferences, go to the advanced to get address information. The if command can also be used sometimes, but you may have additional switches that you need to run, like network setup, tac get info, and then the network service. If you're running wireless, you may have to do Wi-Fi. If you're running wired, you may have to do ETH0. Other commands like the ARP command, this will show us our ARP table, which we discussed all of this in previous lectures. We have a bunch of show commands for verification. Show running config, show interface, show IP interface, show IP interface brief, show IP route, show ARP. All of these are good show commands to look at specific information. All of this allows us to troubleshoot connectivity. We also have a few additional commands like show CDP neighbor. This will show us our other Cisco neighbors. Here's an example of show IP interface brief. Again, you're going to see that it's a brief screen, it's not detailed. We have videos on the show commands. We have labs talking about interpreting the output of show commands. Moving on, we have our troubleshooting methodology. So when there is an issue, what can we do? Well, Cisco actually has an established 6-step process. Identify a problem, establish a theory, test the theory. If the theory doesn't work out, revisit step 2. Once we have actually tested a theory and we know that the theory is correct, we can establish a plan of action and implement the solution. Step 5, verify the solution and input preventative measures. Maybe user training, maybe remove admin functionality. Lots of things that we could do to be preventive here. Last is to document everything. In some situations, it's not always possible to resolve the problem immediately, so you may have to escalate it. You should understand what the company's policies are about escalation. You should also understand there might be a time-sensitive component. Are there agreements in place that issues have to be fixed within a certain time frame? Additional commands for looking at troublesome areas could be turning on the debug command. This will give us a huge amount of data, and this will actually be more than what a typical engineer would ever look at. When we're having to dive deep into what a problem is, debug is going to be there. But debug gives us way more information than most people can interpret. We can actually look at and dump data using our debug command. We also have the ability to monitor the terminal. So let's go and look at some troubleshooting scenarios. If we're looking at an interconnecting Ethernet interface that has to be operating in the same duplex, how could we troubleshoot that? Well, we could be looking at a show IP interface brief. This lets us know the services are up, but this may not give us the details that we need. Looking at a show IP interface may give us the details of the speed. On Windows-based machines, if you're not getting an address, we need to understand if we're able to contact a DHCP server or if there is a manually assigned address. We have to look at the network ID, understand if our range is within the network ID's range. Is our default gateway on the same network? Are we out using the same subnet? Things of that allow us to help troubleshoot easier. Can you ping your PC? Can you ping your loopback address from your PC? Can you ping your default gateway? If yes, can you ping a remote service using an IP address? If that works, but internet's still not functioning, may try pinging a domain name. If you can ping an external IP address or remote IP address, but you cannot ping the domain name, then you know it's a DNS issue. What's really interesting is try pinging Google. If Google doesn't work, try pinging 8.8.8.8. That's Google and Google's DNS. Those two services should always be up. That will let you know about functionality. If you can ping 8.8.8.8, but you cannot ping google.com, you know it's a DNS issue. We have a lab troubleshooting connectivity. We have several troubleshooting labs throughout this lecture. And that is this chapter in a nutshell. If you have any questions or concerns, please reach out.